Alrighty, last episode of the fourth season here. We've got 4.4, determining restrictions on composite functions. Eesh. We got a whole lesson here on just the restrictions for it. So obviously, if that's going to be happening, it's got to be a little bit trickier. So let's start with this first part here. Just getting started. Solving each quadratic inequality. Ooh, see what we can remember on this. All right, first thing, I'm going to show you the method of the test cases again. Going through, let's change it to an equal sign. So x squared plus 9 equals 25. Let's work it through this way. So now we've got x squared equals 16. Square root both sides. X is equal to plus or minus 4. When you take the square root, plus or minus. So this tells us that at -4 and +4, we've got some critical values. So we're going to draw our number line and do -4 and +4. And we're saying we've got 3 different sections now. Anything below -4, between those two numbers, and above. Let's pick a test case inside each one of those. A value less than -4, hey, -5 works great. A value between 0, always choose 0 if you can. And a value above, let's choose 5. Let's plug it into the original function here and see if it's true or false. So we've got -5 squared plus 9 less than or equal to 25. Is that going to be true? We're going to get -5 squared is 25 plus 9. Hey, we already automatically know that that's going to be more than 25, so that's false. That means it's not a solution set. Between the two, plug in a 0. 0 squared plus 9 less than or equal to 25. Yep, 9's less than or equal to 25. That's true. And same thing with 5. 5 squared plus the 9 less than or equal to 25. And again, 25 plus 9, that's more than 25, so that's going to be false. We know at this point then that our solution set is between these two numbers, between 4 and -4, and we look at it and say, do I get to include those numbers? And because it was equal to as well, less than or equal to, I'm going to put dots in there. There's my number line, and now I can just read it off there and say, oh, it's between, here, x value is between 4 and -4. All right, first one, but you know what? I'm actually only going to do A. I'm not going to do B for this one. I just save you some time. But I know you're all excited. You know what time it is. It's lady time. Here she comes.
Use the functions f at x equals 2x minus 1 and g at x equals x squared minus 2. State the domain and range of each function. Sketch a graph of the composite function y equals g at f at x. State the domain and estimate the range of the composite function. The graph of the function f at x equals 2x minus 1 looks like this. Its domain is all real values of x. Its range is all real values of y. The graph of the function g at x equals x squared minus 2 looks like this. Its domain is all real values of x. Its range is all real values of y greater than or equal to -2. I need to find points in the graph of y equals g at f at x, so I'll start by finding points on the graph of y equals f at x. When x equals -2, f at x equals 2 times -2 minus 1, or -5. When x equals -1, f at x equals 2 times -1 minus 1, or -3. When x equals 0, f at x equals -1. When x equals 1, f at x equals 1. When x equals 2, f at x equals 3. When x equals 3, f at x equals 5. Now I can find points on the graph of y equals g at f at x. When x equals -2, f at x equals negative 5. So g at f at x equals negative 5 squared minus 2, or 23. When x equals negative 1, f at x equals negative 3. So g at f at x equals negative 3 squared minus 2, or 7. When x equals 0, f at x equals negative 1. So g at f at x equals negative 1 squared minus 2, or negative 1. When x equals 1, f at x equals 1. So g at f at x equals 1 squared minus 2, or negative 1. When x equals 2, f at x equals 3. So g at f at x equals 3 squared minus 2, or 7. When x equals 3, f at x equals 5. So g at f at x equals 5 squared minus 2, or 23. Now I can plot the points. Negative 2, 23. Negative 1, 7. 0, negative 1. 1, negative 1. 2, 7. 3, 23. Now I can join the points with a smooth curve. This is the graph of y equals g at f at x. The domain is all real values of x. To find the range, I need to figure out the coordinates of the vertex. The x-coordinate of the vertex is halfway between 0 and 1, so it's 0.5. Y equals g at f at x, so I can substitute x equals 0.5 to determine the y-coordinate of the vertex. F at 0.5 equals 2 times 0.5 minus 1, which is 0. G at 0 equals 0 squared minus 2, which is negative 2. So the y-coordinate of the vertex is negative 2. This means that the range is any real value of y that is greater than or equal to negative 2.
There we go. That was good stuff again. Great as always. All right, let's look at ours now. We're going to take what we just learned and try it out for ourselves. Use the function of that and that. So let's state the domain and range of each to start with. Okay, well, we know that first one. Hey, that's a line. That's linear. So it's XER, YER. Good, that one's easy. Hey, this next one. That's a parabola opening down. Let's just rewrite it. Is negative x squared plus 4. They're trying to be tricky by throwing it a different place there. That's at 4 going down, so it's still XER. It's a parabola. But y is less than or equal to, because it's going down, 4. That's where that vertex is. All right, let's make one of those fancy-dancy table of values going here. We got an x. Then we've got inside function. Whatever the inside function is what we're writing here. Good. And then we've got the whole thing. F of g at x. Let's pick some values. Hey, you know what? The values we've been using so far are good as any. Negative 3, negative 2, negative 1, 0, 1, 2, 3. If you're picking values for yourself, pick some negatives, pick some positives, pick 0. See what happens at all those places. All right, let's carry it through. First one, let's find what happens at negative 3 on the g. So that gives us g of negative 3 equals 4 minus negative 3 squared. That's 4 minus 9. That is negative 5. Put that in there. Hey, let's carry on through for the next one. Let's do the whole thing all the way through. Actually, I'll just take this one straight across here. Let's take that negative 5. Let's plop it in here. So that negative 5 is going to go in for right there, the g of x. Oof, that was crazy there. Let's do it. So we've got f of negative 5. So we're taking that straight in for the f now, the outside function. And we work it through. So that gives us negative 5 plus 1, which is negative 4. Bring that back in, and we've got negative 4. Carry it through. Do the next one. All the way down, all the way down, all the way down. It's a good idea at this point for you to pause the video. I'm just going to throw them down. I'm not going to show you the algebra for each one of these. It's a really good idea for you to do the algebra yourself. Don't just blindly copy these and see if you can get the same answers as me. I'll do one more for you just to make sure you've got it. G at, we're taking -2, starting with the inside function. Plop it through. Look at that, going great. We've got 4 minus 4. Hey, that's 0. Boom. Now we go to the next one. Take that and put it into the outside function, which is f. So we take that straight into there and work it through. Work it. Whoop, work it. There we go. 0 plus 1. Look at that. That's 1. That's coming down into there. Keep going all the way through. Now's a good time to pause the video. Make sure you've checked it out. I'm going to finish the rest of them for you. All right, there's the answers. I hope you weren't being lazy and just copied them down without doing the work yourself. I should have probably thrown a couple mistakes in there just to keep you on your toes. And now we want to plot all those points, and by the power of technology here, I'm just going to plot mine right there. Here it comes. So we've got all of our different points that we can see. At 0, we've got 5. That's that point right there. Okay, at -3, we're at -4. That's that point right there. At 3, we've got -4. That's that point right there. Just plot each one of the points on the graph and you got it done. And the final question, the important question of this, what's the domain and the range of this graph? Okay, well, let's just look at the graph, go through the motions, graph it, and say, hey, there we go, it's XER, and Y is less than or equal to that value right there, which was 5. Boom. All right, now we're looking at the actual restrictions information. And for some of you, you're going to need to pause this, you're going to need to rewind this, and re-listen to it. Okay, I'll explain it again in class for those people that need the assistance with this. It is a bit of a tricky concept because we got so much going on here. Let's first of all look at our domain and range of the originals. For f, it's a square root, so that means we can only use x values that are greater than or equal to 0. For the range, the y is also greater than or equal to 0. So we're talking about this one right here. Okay. And for the g, we're looking at this one, and we know that it's also XER and YER because it's a line. Here comes the tricky part. Right. So for this constant function now, the domain is restricted to x is greater than or equal to 0. We just talked about that. That's our outside function. Look at that. We know that the f has to have an input value that's greater than or equal to 0, because that's where we can't take the square root of a negative number. So our input value that's going into the f, whatever we're going to put into the f, has to be greater than or equal to 0. And that's what they're talking about here. That the g has to be g is the input value into the f. It has to be larger than 0, above the x-axis. That's what this is meaning. So in order to be inputted into f, it's got to be positive. Where on the graph of g is it above the x-axis? And we're saying everything that's greater than or equal to -3. That's above the x-axis. So that gives us our domain now of our composite. We know that for the domain of the composite, x has to be greater than or equal to -3. Let's go the other direction. G of f at x. So same kind of thing. we first of all look at the outside function. Is there any restrictions on the outside part of it? Is there anything that I can input into that I cannot input into G? Oh, G was XCR. So there's no restrictions on the G. I can put in whatever I want into input into the G. So that means f of x could be whatever it's allowed to be. And in this case, there's a restriction on that f which is greater than or equal to 0. There's no restriction on the G. So I can input whatever f allows. So my answer is going to be x is greater than or equal to 0. And that's this part here, which is also the same restriction as what f had. So we write x is greater than or equal to 0 as our domain. And they've got that in general there. In general, that's only defined for x equals a if a is in the domain of the inside function. If a is part of the inside function and the g at a, which is an element of the range of g, is in the domain of f. Oh, what the heck does that mean? Well, let's work with it, and it makes a little more sense. And as you can see in this next question, there have to be restrictions on the original f and g in order for there to be restrictions on the new f at g. And again, for time, I'm not going to do both of these. I did A in last one, so I'm going to do B for this one here now. Alrighty, let's put her together. Let's get an equation based on this, and then get its domain, the restrictions on it. So let's start with the equation. Take the inside function and stuff it into the other one. So we're taking this and stuffing it in for the x on the other one. Let's do it. So we've got f of substitute x squared minus 4x. So into the f, put the x squared minus 4x wherever you see an x. Oh, there's one, x squared minus 4x plus 3 equals 1 over x squared minus 4x plus 3. Perfect. Done deal. That was not too bad. All right. For the restrictions, we start on the outside now, which is opposite of what we did when we're working it through all the way through. We always start on the inside and work the way out. But for restrictions, start on the outside. Is there anything that you're not allowed to put into f? So, look for restrictions on the f. And, oh yeah, there is. There's some restrictions here. We know that x cannot equal negative 3. That's an NPV of it. So that means the input value into f cannot be negative 3. Well, what we're inputting into f is the g at x. We're inputting g into f. So because of that, because g is taking the place of this x, the same restriction has to be put for g, the input value. So g at x cannot equal negative 3. We need to find what value makes g negative 3. So let's substitute that in there and say the g, which is x squared minus 4x, that can't be negative 3. Let's work it through. Now I see why that first question was solve the inequalities for quadratics, because that's what we got to do here. We're going to do the same thing. Let's take that. Let's pretend it's equal. X squared minus 4x equals negative 3. Let's take it and work through, isolate it, get it to 0. And actually I can just keep it does not equal for this one. And let's factor that baby. If it was a greater than or equal to or less than sign that's coming in there instead of a not equal, then we would want to use what we did in that first part, where we just made it equal to 0. We used the test cases and work it through here. But this one we can just factor. All right, we got x minus 1 and x minus 3. does not equal 0. So that means x cannot equal 1 and x cannot equal 3. There's our domain. We're done. Let's highlight that, box that in. There's our answer. That's the restrictions that we can, those are the values we cannot use in this equation. Those are really going to be the asymptotes that we would have. And we can see that if we look here and take our rational equations and rational functions chapter we've already talked about and say, where are our NPVs of this one? This was our graph, our equation. Take the NPVs on that, and it's going to be the same. That would factor into the same thing, and x cannot equal 1, and x cannot equal 3. So you can do it either method there. All right, looking at these two, which one should I pick? I'm picking B, because the reason being, on the first one, G was x, okay, XER. As soon as there's XER for the outside function, that's no fun. We know that for this one, if it's XER on the outside, we're just going to be looking at the restrictions of the inside. So x is greater than or equal to 0. Ah, there you go. Well, I just did A, even though I said I wasn't going to. I'm doing B now. Here we go. This one's more fun. Let's start the game again with, let's get an equation. So the G I'm stuffing into the F. So let's stuff the G inside of the F. Wherever I see an X in the F, I'm putting x squared minus 4. So there we go. Square root of x squared minus 4. So again, we could look at it and say, what values on the F inputs will not work. So I could use that method and say F had a restriction of x greater than or equal to 0. So the restrictions on F mean that this, what I'm inputting into the F, has to be greater than or equal to 0. So x squared minus 4 greater than or equal to 0. Or you could say, let's look at the equation. I can't take the square root of the negative number. That means x squared minus 4 has to be greater than or equal to 0. It comes to the same thing. Two different methods of thinking about it, though. That's all it is. So x squared greater than or equal to 4. Now, as soon as you get a quadratic and you get this here, there's really three different ways that I'm going to explain this. First thing, I would actually say, okay, let's not take it to this point. Let's go from here and factor. That's a difference of squares. X minus 2, x plus 2, greater than or equal to 0. We could factor it and say, I've got to change this to an equal sign. As soon as we do quadratics and inequalities, we're going to use those test cases. So let's find our critical values first. X is equal to 2 and x is equal to negative 2. Draw your number line. All right, we've got x equal to negative 2. We've got it in 2. Let's pick our test cases. Something on the left side, negative 3. Something in the middle, 0. That's always a great one. And 3. And then plug it back into here, your x squared minus 4, and see if it's true or false. So the first one there is true when we plug it in. The second one becomes false. And the third one, we're going to get true again. That means for our solution, it's to the left of negative 2. It's to the right of 2. Those are the true sections. And now we look back at the original, and we also could be equal. So we fill in a solid dot. And we look at, that means that x is less than or equal to negative 2, and x is greater than or equal to 2. There's our domain. The other ways that we could do this is taking it from here. And this is the trickier method. I do recommend going with that first method. The second method would be if we do the square root of both sides at this point. Now, we've always done, before this, we've put the plus or minus on the number side. But when we're dealing with inequalities, we don't want to put them there. We're going to put them on the number with the part with the variable. The reason for that is it actually went with both parts, and it was redundant to put it twice. We could put it on either or. There are some extra rules with inequalities, and that is you've got the positive square root of x squared, which is x, greater than or equal to 2. And we've got the negative side, greater than or equal to 2. So the first one, that's good to go. Hey, x greater than or equal to 2. Boom, that's the first one. The next one, we want to solve for x again. So I've got to divide by negative. Ooh, we got a rule. You divide by negative, you got to flip the sign. There we go, flipped it over there, baby. And that gives us the second one. Boom, there. So there's two different methods. Be careful if you use the second one. You got to put the plus or minus on the variable side. All right, everybody loves this next part. Nice. We're working backwards here now. We're saying, hey, I've got my composite function. What was the originals? This is a game. So first thing we're going to do, use some of your skills from the transformations. If we've got something stuffed into another one inside brackets, hey, let's just make that one of the functions. So in this case, when we look at this h, we can say, right here, we've got something stuffed inside with the x. Let's pull that out and make that its own equation. So then that slides through right there. We've replaced that x minus 3 with a g at x. And then we say, wherever we put that g, just put an x there, and we've got the other equation. Okay. So let's take a look further at our own. I'm going to do both of these now because it actually gets a little bit quick for this part. Look at your first one. Is there anything stuffed inside of brackets into the other one? Sure is, right there. Let's take that out and make that the inside function. In this case, the g. Oops. And now wherever I put that in there, what I did is I substituted, so I said really y is equal to that. Or I took this g inside of there. Well, just change that to an x, make this into an f, and we've got the second function. First one, second one, done deal. Let's look at the next one. Again, identify anything that looks like it's been stuffed. Hey, there's real brackets there hiding in there. So let's take that inside the brackets, pull it out, make it into a g. So right there, g is going to be 3 plus x. Now, whatever you took out of that equation, let's cross that off and make that into an x. And that's your f equation then. So then f is equal to the root of, with that substituted to the x. Bang on, we got it good. Okay, so we could get real fancy here. We could go stuff inside of stuff inside of stuff, just keep stuffing her in there. In this case, the x squared, hey, that could have brackets around it. And we could have the x squared right there. Oops, I kind of got going there. So we could say x squared, that's our first one. Which then leaves us with the next level, right there, the g. Which then leaves us with the next level, which is there at x to the 4. We could go 3 levels on that one. And again, this learning is for you, not for me. Hit your 2 questions, get the thinking down, go deeper into these concepts. The further you go, the better you understand them.